Okay. The percent of U.S. households that access the internet by dial-up. Okay? Percent, and I'm going to put some more thing over here for my graph. This is the percent who access the internet by dial-up. Is it going up or is it going down as the years go forward? It's going down. Do you buy into that?
Yes.
How many of you used to have dial-up and now you have high speed? You still have dial-up. Okay, okay.
When you go to high speed,
You just no go back. That's right. That's exactly right. Once you go to high speed, it's...
We can't get cable where we are.
Oh, if you can't get, yeah. So, okay. So they made some tallies, and they found out in year 0, now they tell us in here that year 0 corresponds to year 2000. So this is in year 2000. Year 0, it corresponds to year 2000. The first year after year 2000, only, and so in 2000, 91% were accessing it by dial-up. In 2001, about how much? What would you think this one was? 83, yeah. So about 83% was accessing it by dial-up. In the second year after 2000, in year 2, okay, 78% were accessing the internet by dial-up. In year 3, 71. In year 4, 68. And then in year 5, which is and this is estimated because this book was published before that year 2005 actually rolled around. But here we are, 2005, only about 68%. So you guys still fall into that 68%. So still more than half are still accessing the internet by dial-up. When we plotted these points, they look sort of like a straight line. Now, they're not exactly on that line, but they're sort of on that line. They're sort of linear. So what we want to do is we want to try to write an equation that could help us predict, say, if it keeps on going in this same pattern, we're going to be able to predict, and that's what they're going to ask us to do, predict what percent will access the internet by dial-up in year 2006. We can do that, we can find that prediction if we'll write an equation that will give us the percent based on the year past 2000. Okay? So we're going to do our identify here. X is standing for. X is going to stand for the number of years past 2000. And we're going to be able to find a Y value, so that's going to be the percent accessing by dial-up, or dial-up percent. Something that helps you think, okay, what my Y quantity is about is the percent that are accessing the internet by dial-up. It looks sort of like a line. So if we have something that looks sort of like a line, we should be able to find the slope of that line. Okay? So let's do that. Okay? Now, you're going to pick 2 points. It doesn't matter which 2 you pick, but if you pick some, if one of you picks this pair, and one of you picks this and this one, your slope will be slightly off, because these aren't all perfectly on that line. In the textbook problems, they all fall right on that line. It's perfect. But in a real-life kind of problem, they're not perfectly on that line, but they're close to it. So we're going to have to decide which ones we're going to use. It doesn't give us a special one to do. It says just use ordered pairs. So we're going to have to pick a pair. How about let's pick, which ones do y'all want to pick? This one? If there's one with a 0 in it, it's usually easier. And this one.
Because they're both on the line.
Because they're both on the line, yeah. And the other ones are close to the line, but not exactly on it. Okay. And it just happened to be that they drew this line for us. But Kimberly, it could have been just as easy that they could have drawn another line, say, let me put it, I won't even draw it, but with my little finger here. They could draw a line right here. Right, and then those would still be close, and maybe we would use those 2 data points to find the slope. Okay, so, but we're going to use these 2 points. We're going to use 0, 91 and 5, 63. we're going to find the slope there. So because you've done your ECC math and you've practiced that slope, this is easy for you now. So we're going to get 63 minus 91 divided by 5 minus 0. And we get 63 minus 91 is a negative 28. If I had 30, it'd be 93. Yeah, that'd be right. Divided by 5. And let's go ahead and put it as a decimal, because divided by 5 will give me an easy decimal. That's going to be a negative 5.6. Because it's 5 3/10, which is 5.6. Okay? So that's the slope of this line. And it asks us a question there. Well, what does that mean? What does the slope tell us? You guys already knew this by looking at the picture. The picture's so powerful.
That it's decreasing every year.
Okay. Decreasing. The Y value, the percent accessing by dial-up, is decreasing each year. Okay, tell me what questions you have so far. So now that we have a slope, we can pick either one of these green points and write an equation, because we have our point slope. Anytime we have a point and a slope, we'll go into that template, that point slope form, and be able to generate an equation. So let's go to the next slide to do that. All right, so what we're going to have here is, let's see, we had our two green points, which were 0, 91, and what was the other one? 5,63. All right. And we know now the slope is a negative 5.6. You can pick either one. All right, we got 4 and 4. Okay, this is 4. Kathleen, Christian, Montreal, Carla. I want you guys to use 0, 91. And Nora, Demetria, Violetta, and Kimberly, I want you guys to use this one. Use that point. And where am I going to have you do it? It's right here. Okay. Groups did this. One group used the 0,91. The other group used the 563. Everybody got the equation is going to be y equals negative 5.6x plus 91. No matter which point you used. Remember which point you used, you got that. So now if we had to predict.
57 was the right answer. Had I used my calculator right this one.
Okay, well, I'm going to do this one here. So predicted in 2006, what is your x value?
It's going to be 6.
It's going to be 6. Okay, because it's 6 years after 2000. So be real careful about your equation there. And so then you're going to plug that in for your x, and you get 57.4, but it says to round to the nearest whole percent.
358.
In 2006,
Oh, no, it'd be 57.
it would be 57. 57% of the households will still have dial-up. So you're not too, I mean, there's still the majority of people who still have dial-up. Okay, so, all right. That was an example of a linear model. All right, let me get you started on another one here. Okay, if you look at the USA Today. And if we thought about this bar graph having points, we have a point here, and a point here, and a point here, and a point here, and a point here. We can kind of see that this is sort of rising linearly. We're going to pick two that we're going to have to draw through. So let's draw through this one. and this one. Okay, in other words, when we look at that information, it's starting to look like it's increasing linearly. They're related to each other linearly. I better give you that back before I leave. Okay, so what we're going to do is we're going to find this model, find this equation that will give us spending in terms of a number of years, but this time the number of years is after 1990. So let's go back and let's be real careful. X stands for number of years after 1990. Y is going to be spending in billions. Okay. So what we want to do is predict that in 2004. We have to find our model first, find our equation first, and then predict it. So we're going to have to find, what are we going to do to find our model? We've got to have a strategy here. Okay? Okay. So we have to choose our points. So what are our points going to be? What's 1997, comma 79? What should I put for the X there?
1.
Tricky, isn't it?
You put 1997.
Look what we said here. Well, 7, because X stands for the number of years after 1990. Yes. 779, and that's in billions. So in 1997, we spent $79 billion on prescription drugs. All right. The other point is going to be, what's going to be for the X there? Okay, 2001 is how many years after 1990? Yeah, because this one here. The 10, if you pick that other one, it'd be 10, and your slope would be just a tiny bit off of somebody else's, and that's okay. 11, 155. Okay, so we're going to go find the slope of that line. So 155 minus 79. Here I'm 11 minus 7. I didn't write my formula down, but it's the difference of the y's divided by the difference of the x's. So it's going to be 76 divided by 4. Did I get my math right? 5. 55 plus 21. 76. So that will divide by 4. It looks like it's going to be a something. 0.5. What is it? Okay. 19.5? 19 exactly. Oh, okay. 72 would be the, okay, 19. Okay. Christian, are you going to get the dollar disc for me this weekend and do that slope practice? Please, because it will make this help. This will help a lot. It helps a lot. Yeah, I mean, you just need that reinforcement of that. But, I mean, the 11 and 7 when I wrote the points, okay, well, X, when I wrote this down here, X is standing for the number of years after 1990. Okay, so this is 7 years, 1997 is 7 years after 1990, and 2001 is 11 years after 1990. That's what I'm going to put for my X values there. Now we can go to our point slope, and it doesn't matter which one you picked. That's what I wanted you to see from that previous example. With 4 of them doing it with one point, the other 4 doing it with the other point, we got the same model. It does not matter which one you pick here.
So you just pick it 19?
When I looked at my graph, since they gave me these numbers, I went ahead and used this point right here, which is 779 on this line, and thinking about this in terms of X and Y. Right, and it says it in the description. And so in other words, we are going to try to write a model. Instead of having to use the big numbers, 1997, we're just going to think of this as the number of years since 1990. So we're going to pick anything. I'm going to pick the first one. Y sub 1 is 79 equals 19 times X minus 7 So 19 times 7, 133, thank you. Add 79. And negative 133 plus 79. Then it should be negative, right? Okay, negative 54. So, make your prediction. Let me see your sentence. And I'm going to give you your test back.